Now we're going to practice what we've just learned. And again, there's no 100% only right answer to how you could say these examples, but we're going to practice them based on what the book had told us. So here we go. I'm not going to write these, but I'm going to read how the expression would read. This would say -2 equals -2. But it could also be the opposite of 2 equals the opposite of 2. They would mean the same thing. But it means if I take away 2 from nothing, I will have -2. And here if I take away 2, I'm taking away a positive 2. And if I take 2 away, it's the same as up here because this is taking away a positive 2 as well. We just don't write the positive 2 in front of there because it's implied. So now if this is the operator taking away positive 2, I still get -2. That's why they are exactly the same. -2 and minus positive 2 are the same thing. They're both going to be -2. Now what happens when we mix the two signs? The other way. Here we had minus positive 2, now we have plus -2. Look at, interestingly, these all three say -2. Because if I add the opposite of 2, I get the opposite of 2. Because there's nothing over here. So 0 plus -2 is -2. And then below, we throw in the symbols of enclosure. But again, two signs, only one can win. Okay? And that's another way I'm going to back and show you. But this is the opposite of positive 2, and that would be -2. So although we're saying -2 every time, here we said minus positive 2 is -2, minus positive 2 is -2, and plus -2 is -2, and the opposite of positive 2 is -2. They're all really the same thing, but multiple ways to say it. Another way that I like to look at it is a number has only one sign. So when there are multiple signs out in front of a number, like example 2, 3, and 4 here, negative, when we're adding and subtracting, negative always wins. So because each of these has a negative, the answers are all negative. If they were positive, positive, the answer would be positive, and if there were two negatives, it would still be negative in addition. Now, if you already know multiplication rules, you know that that's different. And that's where people tend to get confused, is when they don't solidly have the addition and subtraction rules before they learn the multiplication rules, which are different. But in the case of adding or combining sign numbers, it only has one sign and the negative always wins. So let's simplify down below. Here we have symbols of enclosure around a -5 and a -3. But if we cleaned that all up and took everything away, the first one can only have one sign. So I'm just going to write that. The first one is -5. I don't need the parentheses. They're not doing anything. Parentheses only do something if there's something inside that can be simplified, or if they're directly next to something and they apply multiplication. Because there's an operator in between here, and the operator in between is addition, right here, because that's addition. This is not multiplication. Those parentheses are not doing anything. So I can remove them safely and just get down to the signs. Now, remember I told you that although this -3 has a positive in front of it, a number can only have one sign. And the negative always wins. So we could just say that this is -3. So I have a -5 and a -3, and I'm always doing what we call algebraic addition. I'm combining two signed numbers. So when I have a -5 and a -3, my answer has to be negative, because nothing's going to make it go positive. I'm already at -3, and I'm going to go at -5, and I'm going to go down -3 more. I'm going to be at -8. One way that I think people understand this a lot is with money. Because this problem could just as easily represent this situation. I borrowed $5 from you. Okay, I borrowed $5 on Monday, and on Tuesday I borrowed 3 more. I owe you $8. A lot of times people understand this when you think about money. That way you don't come up with -2 or +2 or +8. If I borrow $5 and borrow 3 more, I owe or I have -$8. Okay? So maybe that will help a little more. Now on number 6 over here, again, the symbols of enclosure aren't doing anything. So I have a -2, and then I have plus plus or plus +6. Remember, two signs, only one wins. And since they're both positive, I only need one of them. A positive will never change to a negative by multiplying or by adding it to another positive, because it's like plus +6. And that is just +6. But now I have mixed signs in my problem. And remember, I have a +6 and a -2. I can always look at this that I know the answer is going to be positive because the bigger number is positive. That's one way to look at it. And then I only ever need to know the difference between the two. The difference between 6 and 2 is 4, always, right? Whether the 2 comes first or the 6 comes first in the problem, the difference between them is 4, or the space between them. And in this case, it's +4 only because the 6 is the bigger number. And I don't have to write a plus sign in front of the 4 because remember, no sign at all assumes positive. And I could rewrite this problem because signed numbers can be changed as long as you take their sign with them. I could make the 6 first and the -2 second. And because I don't have to write plus in front of the 6 because it's assumed, it just becomes 6 minus 2, which is also 4. I think a lot of people can see that 6 minus 2 is very familiar and friendly as opposed to -2 plus 6. But they are the same thing. Although we say that subtraction isn't commutative, as long as you take the signs with them, in a sense, you can make it commutative because you can move them around as long as you take signs with them. So 6 minus 2 is the same as -2 plus 6. And both yield a +4 because the 6 is positive, it's bigger, and it wins. Continuing on to number 7, we have a lot of parentheses which are not accomplishing anything, so we can immediately get rid of them. We don't need a plus sign in front of our 1, so we just write 1. The plus and the minus, remember, only one sign is necessary, negative wins. So now we have 1 minus 7. That's a little, we can't rearrange that to make it easier like we did the 6 and the 2 because the negative in this case is bigger. We know the answer is negative because the negative number is bigger. And we just find the difference between 7 and 1. So it is 6, but it's 6 because of the absolute value difference, or the difference between 7 and 1 is 6. And the negative is coming from the 7 being a bigger number. So number 8, we have a 9 in parentheses, which looks kind of funny. It's not really doing anything, so we're just going to get rid of the parentheses. As long as they're not implying multiplication, they're not necessary. Now we have plus a -3, and we know that one sign is enough, and we know that negative wins, so it's really 9 minus 3, which should look very friendly. I don't think any of us doubt that 9 minus 3 is 6, and we don't have to think about the sign. It's very comfortable. As long as the positive number is larger, we've been doing subtraction a long time, we don't seem confused by that. But when we throw the parentheses in, and we put plus a negative, suddenly we think it's a different problem. So if we simplify the problem to something more comfortable, it's an easier problem. So looking at number 9, all that we've added in here is a third term, but what we have is 3 sets of parentheses, all with addition in between, so we know there's no multiplication, so we can safely remove our parentheses. We can write +7 as 7. When we have plus +6, we can just write +6, because two signs, we only need one. They're both positive, so it must be positive. Now we have mixed signs, plus -1. Only one sign can win. The negative always wins. So we now have a simplified problem. We have +7, positive 6 and negative 1. If we combine our positives first, we're going to get 13. We don't need the positive sign. We know it's a positive 13. And we still have our negative or minus 1. And now we pretty easily see that 13 minus 1 is 12. So again, we just keep simplifying until it looks like something that we're familiar and comfortable with. Our last example, number 10, again, 3 terms, 3 sets of enclosures that are not implying multiplication. So we can simplify this to negative 2, negative 9, and positive 11. I went a little faster that time, but you can see that plus negative 9 is really negative 9. And the problem is starting to get easier. It might be confusing at this point because it's not as comfortable to have the negatives in the front. But remember, we could reorganize the problem. This would be one way to do it, is put the 11 first, then the negative 2, and then the negative 9. And some of you, that might help. That might make it look more comfortable. And I'm not sure if that does, but if that helps, that works. Another thing we could do is now we could go in any order we really want to, but some people like to organize it where you add your negatives together first because we know that adding 2 negatives gives us a bigger negative. So we could leave our 11 alone. We could take our negative 2 and our negative 9 and make them negative 11. Because if I owe you $9 and I borrow 2 more, I owe you 11. Or if I borrow $2 and I borrow 9 more, I owe you 11. And now we're very comfortable with 11 minus 11 is 0. Again, if we'd done that up above, we could have gone left to right and done negative 11 plus 11. This would also be 0 because opposites cancel each other out. If I have a negative 11 and a positive 11, I will have 0. It's the same as down here, only we don't have the positive sign because we don't lead with a positive. It's assumed.